Okay, so the big question, how do we approach physics problems from the beginning? I like to start with just knowing the formulas that you're going to use and laying those out so that they make sense. So we're going to start with 5 formulas, and these 5 formulas will get you through the majority of the school year. Seriously, this will get you through a lot. Plus, when you get to rotational motion, separate sidebar, a lot of these are going to be the same, with just a slight variation in how the things move, but the layout of the formulas are going to be identical. Okay? So get to know these well. This is velocity or speed. Velocity is speed in a given direction. That's speed is distance over time, velocity is displacement over time. So it's the same algebra, same formula, but notice that's for constant speed. So we're not accelerating, not speeding up, not slowing down. So velocity is distance over time for constant speed. The next one is for acceleration. Acceleration is v final minus v initial over t. In other words, final velocity minus initial velocity over time. And so algebraically rearranging that, multiplying both sides by t, we get at is equal to v final minus v initial. Now, anytime you have a final condition minus the initial condition, we call that a change in. So we have a little Greek letter delta. Change is final condition minus initial condition. So if you ever see v final minus v initial, t final minus t initial, d final minus d initial, whatever it is, final minus initial, change in. So then we have the average velocity. So this, with a line bar over the top, velocity, is average velocity for constant acceleration. Notice up here we were talking velocity for constant speed. If it's not accelerating, down here we say if it's doing constant acceleration, then we can say the average velocity is equal to the end velocities, v final plus v initial, divided by 2. So it'll be the velocity in the middle of that whole range of velocities. And it's also equal to total distance divided by total time. So it doesn't have to be going constant velocity for us to calculate that. We can say if it's accelerating constantly, we can take distance over time, total distance over total time to get the average velocity. That could be even irregular acceleration, but that's a separate discussion. So this right here is for distance. This could be vertical distance or horizontal distance. It really doesn't matter. We're just going to call it final distance is equal to 1/2 the acceleration times time squared plus the initial velocity times t plus your original distance. Most of the time, d original is going to be 0. So this is not even going to be there. So if you think about this, d final minus d initial, subtracting d initial from both sides, then would give us delta d, or change in distance, is equal to 1/2 a acceleration time squared plus v initial t. T is for the time, v is v initial, a is acceleration. And then the last one is v final squared minus v initial squared. So if we're taking a difference in velocities squared, that's equal to 2a delta d. So 2 times the acceleration times the change in distance. Now, I'm going to rewrite this. So we have 2 times the acceleration times d final minus d initial. Now this is important because if, for example, something is falling, then final is going to be less than initial. So we're going to subtract the larger number. So this will actually be negative. So if something is falling, you stand up on top of here and you drop something, change in distance or change in height is going to be negative, whatever that height is. So if we throw something up in the air, then our change in height is going to be positive. Change in height will be positive. So just noting that would be worthwhile to know. So now, we had a question that said, which of the 3 things is traveling faster after 1 second? A ball that's thrown with an initial velocity of 6 meters per second up, a ball was thrown at a velocity of 4 meters per second up, or velocity of a ball thrown at 1 meter per second up. So here's what we need to look at. What is the question is, which ball is traveling faster? So V final equals I don't know, V final equals I don't know, and V final equals I don't know. V initial we know. V initial is 6. And V initial here is 4. And V initial here is 1. So now, what else do we need? Well, the only other thing we don't have here is the time. Time is 1 second. Time was given as 1 second. So which ball has the greatest velocity after a 1 second launch? Well, we have V final, V initial, and T, and we're asking for V final. So here's our equation right here. So if you look at the list of items that it gives us is V final, question mark, V initial, T, and 6 meters per second. The one thing they didn't give us was acceleration, but we know that's -10 because it's falling. It's being thrown vertically upward, so the acceleration is constant, and it's always, for every object that's thrown in the air, any projectile, at -10 meters per second squared. That's to say it changes -10 meters per second every second. Okay, so our acceleration is -10, A equals -10, A equals -10. So now we plug that into this equation right here. AT is V final minus V initial, so we could say down here, AT plus V initial is V final. So, using this equation, because that's from our equation list, and here's the list of variables that were given in the problem, 6 meters per second is V initial. A is -10, and T is 1 second. So our AT is going to be -10 plus V initial of 6 equals -4 for the first one. And it's going to be the same setup, -10 plus 4, which is equal to -6 for the second one. And then -10 plus 1, which is -9 for the last one. So in ranked order, this one will be fastest, this one will be second fastest, and this one will be third fastest according to the original problem.